compass traversing means when we are going to do surveying, okay, we have to take the instrument compass for traversing. Okay, so in compass traversing there are two types of magnetic bearing. Okay, magnetic bearing, that is WCB and QB. WCB means whole circle bearing. Okay, whole circle bearing. And QB means quadrantal bearing. Okay, two type of bearing. So what is WCB bearing and what is quadrantal bearing? So let us know. Okay, so in this case, this is north, this is south. Okay, and this point is your east and west. Okay, four directions are there. So when we go for WCB system, in this case the bearing will be calculated from 0 to 360 degree. 0 degree to 360 degree. Okay, in WCB system. Okay, let's suppose there are some lines. Let's suppose this is point O, A, B, C, D. Okay, OA, OB, OC and OD. Four lines are situated in the system. Okay, so when we go for WCB system, let's suppose this is a bearing in WCB. This is OA is theta 1. Let's suppose this is a bearing theta 1. Okay, so WCB of AB equal to or OA equal to WCB of OA. In this case, WCB of OA, this point, okay, OA, WCB of OA is theta 1. Okay, clear? This is the WCB of OA from this line to this WCB system, because it is counted from 0 degree to 360 degree. When we go for OB, WCB of OB equal to, this is OB, it is also count from this line only. Okay, this is from starting point is this is theta 2. Okay, it started from this line, north pole to the line. Okay, from north pole to the line. When it is from north pole to this line OA, and when in the case of OB, it is also started from north pole to the line OB. This is theta 2. Okay, then WCB of this line, that is OC, it also started from only north pole to the line. Okay, north pole to the line OC, that is theta 3. Okay, theta 2 and this is theta 3. And when we go for this line OD, WCB of OD, it is also started from north pole to the respective line. Okay, clear? This is the WCB of OD, that is theta 4. Okay, this is the WCB system. Okay, and when we go for the quadrantal bearing system, this is WCB system and this is quadrantal bearing. Two type of system are there. I am going to go for a magnetic bearing. When we go for a magnetic bearing, two systems are there. One is WCB, another is QB. So WCB means always it counts from north pole to the line, whether your line is situated. Okay, here OA, OB, OC, OD are situated. Okay, so always the WCB is counted from north pole to the line. North pole to the line OA, north pole to the line OB, north pole to the line OC, north pole to the line OD. Okay, this is whole circle bearing system, and it counts from 0 degree to 360 degree. Okay, because whole system is 360 degree. Clear? When we go for quadrantal bearing system, in this system again, let's suppose quadrantal north, south, east, west. Again, 4 lines. Let's suppose this O, OA, OB, OC, OB. Okay. QB system. This is QB system, and this is WCB system. One circuit bearing system. So in QB system also, it counted from the respective quadrant. Okay, it has 4 quadrants. First quadrant is your northeast. This is only in this quadrant. This is southeast quadrant, second quadrant. This is southwest quadrant. This is northwest quadrant. Okay, the quadrant will be counted from only north and south. Okay, have you seen east north or east south? No. Always it counts from southeast, northeast, southwest, northwest. Okay, always it counts from north or south, north pole or south pole. Okay, so in this case, when we go for the QB of OA, in this case, WCB of OA is theta 1 from the north pole to the line only in WCB system. When we go for QB system, we mention the quadrant of that particular line. Okay, that is QB of OA. If we go for QB of OA, QB of means quadrantal bearing of OA equal to, this is your theta 1, theta 2, theta 3, theta 4. Okay, so in this case we have to put the quadrant north theta degree east, north theta degree east. Okay, and QB of OB, QB of OB equal to south theta degree east. Okay, south theta degree east. And when it is for theta 3, that is QB of OC, south theta degree west. Then QB of OD equal to north theta degree west. Very good. Okay, this is the system of QB. Okay, clear? And the magnetic bearing of the line measured clockwise or anti-clockwise also. Okay, and it's always counted from only north or south. This is the difference between your WCB system and QB system. Okay, and also we can convert the WCB to QB and QB to WCB. Okay, in this case, whether your bearing is in WCB system or QB system, we can convert. Okay, WCB to QB also possible and QB to WCB. Okay, only you have to know the reduced bearing. Another bearing is there, that is reduced bearing. What is reduced bearing? Reduced bearing is when the whole circle bearing of a line is converted to quadrantal bearing system. Okay, when this whole circle bearing is converted to QB system, then it is called a reduced bearing. Okay, so which type of calculation is required for conversion? When the line lies between 0 to 90 degree. 0 to 90 degree when WCB is there. 0 to 90 degree means this is the when we go for quadrant, this is 0 to 90 degree. Then it is 90 to 180 degree. Then it is 180 degree to 270 degree, and this is 270 degree to 360 degree. This is quadrantal system because always it counts from 0 degree to 90 degree. When it is 0 degree to 360 degree. Okay, 0 degree to 360 degree, but in this case it is 0 degree to 90 degree. Always it counts from 0 degree to 90 degree. Okay, it is 0 degree to 90 degree, 0 degree to 90 degree, 0 degree to 90 degree, 0 degree to 90 degree. Each quadrant side comes from 0 to 90 degree. This is quadrantal system. But in this case, it is 0 degree to 360 degree. Okay, but the main objective of this WCB and QB is the conversion of WCB to QB or QB to WCB. How it is possible? Okay, this is the main thing of this topic. Okay, so there are some key points are there. We have to first know the line situated from in which quadrant. Like let's suppose 0 degree to 90 degree, 90 degree to 180 degree, 180 degree to 270 degree, and 270 degree to 360 degree. Okay, so first we have to point out that your line is situated in which limit, that is 0 degree to 90 degree, in between 0 degree to 90 degree, or 90 to 180, or 180 to 270, or 270 to 360. Okay, and accordingly we have to find out the corresponding reduced bearing. So this is the WCB between the WCB between. Here, this is the WCB between, and when we go for find out the reduced bearing, when we go for the reduced bearing, that is when it is lies in 0 degree to 90 degree. Let's suppose this is the line OA, it's situated in 0 degree to 90 degree. Okay, and when it is lies between 0 degree to 90 degree, only we have to write the quadrant. Okay, quadrant only we have to write. Let's suppose when the WCB is lies between 0 degree to 90 degree, reduced bearing also same WCB. Only we have to put the quadrant that is not east. Example, let's suppose your bearing is 60 degree. Okay, 60 degree means 0 degree to 90 degree, in between that 60 degree is lies between 0 degree to 90 degree. So in this case, what will be your reduced bearing? If it is 60 degree, north, 60 degree east. Only you have to write it. If your bearing is 60 degree, this is the example. First case, in between, if your WCB is lying between 0 degree to 90 degree, means 60 degree, 55 degree, 70 degree, up to 90 degree. When it is lying in between that, we have to put only the quadrant. Then it is converted to QB system. Let's suppose 60 degree bearing is there, 60 degree, and I asked you convert the bearing. Okay, 60 degree bearing. So the bearing system will be converted north 60 degree east, because it lies between first quadrant, north east quadrant. Okay, let's suppose a line lies between 90 degree to 180 degree, 90 degree to 180 degree. So what will be your WCB? In this case, it's 180 degree minus WCB. Whatever your WCB is there, you have to subtract from 180 degree, and your quadrant is south east. Second quadrant. So one example again, 90 degree to 180 degree means, let's suppose your bearing is 150 degree. Okay, so 150 degree lies between 90 degree to 180 degree. Okay, so what you will do here? We can subtract the 150 from 180 degree. 180 degree minus WCB is there, 150. Let's suppose your WCB is 150 degree. Okay, 150 degree is your WCB. We have to convert it in quadrantal bearing, QB. So in this case, we have to subtract 180 degree minus 150 degree. Please calculate 180 degree minus 150 degree. here, so we can write it in this quadrant. South 30 degree east. Okay, clear? Any doubt? Because your WCB is 150 degree. WCB of the line is 150 degree. Okay, 150 degree WCB means here from this pole this is 150 degree. There is no quadrant. You have to convert it in quadrantal bearing system. So you have to subtract 180 degree minus 150 degree, that is 30 degree, and you have to write south 30 degree east. It converted. Okay, 150 degree is now converted to south 30 degree east. 150 degree WCB equal to, example, 150 degree WCB equal to south 30 degree east. Okay, converted or not? Then next is your 180 degree to 270 degree. In this case, we have to do WCB minus 180 degree, and your quadrant will be what? What is your third quadrant? South. Southwest. Okay. So in this case, let's take one example. 230 degree. I am giving an example 230 degree. Okay, this is WCB. 230 degree WCB is to be converted to QB. So in this case, your WCB is 230 degree. So what are you doing? 230 degree minus what? 180 degree in this case. To find out the reduced period. 230 degree minus 180 degree. Please calculate. 50 degree. So this 50 degree will be written as south 50 degree west. South 50 degree west. That means 230 degree WCB system. This is the WCB system. This equal to south 50 degree west. This is the conversion process. Accordingly, when it lies between both quadrant 270 degree to 360 degree. Okay, let's suppose your example is 280 degree. 280 degree. What are you doing here? You have to subtract 360 degree minus WCB, and quadrant will be north west. That is 360 degree. 360 minus WCB, WCB is 280 degree. So here you have to subtract 360 degree minus 280 degree. Calculate please. 360 degree minus 280. 80 degree. So 80 degree will be written as north, 80 degree west. So 280 degree equal to north, 80 degree west. Okay, this is the conversion process from WCB to QB. Okay, clear? Any doubt? And in general, when we go for WCB and QB, always you have seen that in WCB system, no quadrants are there. Only 250, 60, 30, 40 degree, like that it will be written. Okay, but in QB system, every bearing have quadrant. North 30 degrees, south 40 degree, west, like that. Okay, this is your always in quadrant bearing system, quadrants are there. In WCB system, no quadrants are there, because in WCB system it is counted from 0 degree to 360 degree, and in your WCB system it counted from 0 degree to 90 degree. Okay, this is all about your WCB system and QB system. Okay, any doubt?